Hello everybody and welcome to Pajama Physics. This is just going to be a quick video on some linear motion problems. Okay, so let's get started here. If you hear my dogs, I'm sorry. They're going to be loud. They like to bark at people that like to walk by. Alright, so calculate the vertical distance an object dropped from rest would cover in 12 seconds if it freely fell without air resistance. Whoo boy, starting off with a doozy, am I right? So let's go ahead and start with what we are given. So t is equal to 12 seconds. That's pretty much all that we are given in this problem. But if we look again, we say that it is fell freely. So what does free fall mean? Well, it means that its acceleration due to gravity is negative 10 meters per second squared. And we are to calculate the vertical distance an object dropped from rest. That is another important little information piece right there, right? So if it was dropped from rest, then we can say that our initial velocity for that object is 0 meters per second. Okay, so we have these three things and we are asked to solve for the distance. Well, I know that d is equal to v naught t plus 1/2 gt squared, where d is my distance, v naught is my initial velocity, t is my time, and g is my acceleration due to gravity. All right, so I can plug all of this information in and come out with an answer, but I'm going to go ahead and cross out some things that I know are going to equal 0. All right, so my v naught t, I know that that's going to be 0. Why? Because v naught, or my initial velocity, is 0 meters per second. So I can go ahead and write my new equation just like this. And now I can plug in some information. So 1/2 negative 10 meters per second squared times my time, which was 12 seconds, and that is squared. T is the only thing that is squared in that problem. And I will leave you to find the distance. If you want to know the distance, check in with Miss Brennan later on. All right, let's go ahead and jump to the next problem here. So I am given some symbols and I am asked to identify the symbol and identify the unit. So this little symbol right here, the little triangle, is called our delta. All right, our delta, what does that mean? It means the change in. Well, you might be asking, the change in, like the change in what, right? Well, that is a great question. It all depends on what variable is following after. All right, so you can have the delta you can have delta t, is what I meant to say, delta t, delta d, delta v, we might see that in acceleration. So all it means is the change in whatever variable follows afterwards. So you can have the change in velocity, the change in time, the change in displacement, all of that good stuff. All right, so talking about time, t is actually our variable for time. And we measure time in seconds. A is for acceleration. And the units for acceleration are meters per second squared. G is our acceleration due to gravity, or as a lot of you like to say, gravity, right? And that is negative 10 meters per second squared. Okay, VF is our final velocity. How do we measure velocity? What are the units for velocity? Well, that would be meters per second. VI or V naught, you're going to see it both ways. That is initial velocity. And the units for that are meters per second. All right, let's jump on to some more problems. How can you both be at rest and also moving at 170,000 kilometers per hour at the same time? And that is a great question, right? But we learned in linear motion that motion itself is relative to an observer. It's relative to the observer's frame of reference. All right, so let's look at this. So we are on Earth, right? So we'll draw a little plane here. So we are on Earth. Hello. right there on Earth. And do we feel like the Earth is moving to us? No, right? Like I'm not like slamming against the wall, right? So to us, the Earth is staying perfectly still. But keep in mind, if we changed our reference so that we were on the sun and we were looking at the Earth, we would see that the Earth is rotating. It is moving. So it all depends on the observer's frame of reference for that object. Okay, so you can both be moving and at rest depending on your frame of reference. All right, so whether you're an outside observer or an inside observer. All right. Let's look at this next question. So calculate their average walking speed when you step 1 meter in 0.5 seconds. Well, first thing that we do, because this is a physics problem, we write down our knowns. So D would be our distance. What is our distance here? 1 meter. And we're also given a time. So we have a time, we have some distance, and we are asked to calculate average walking speed, or is average speed. All right, so now let's write the equation for average speed. So average speed is equal to total distance over total time. Just like we did in class with our carts, right? We tracked the amount of time that it took to cover a certain amount of distance. All right, so we were calculating our average speed. So let's find average speed. So average speed in this case is equal to 1 meter divided by 0.5 seconds. So if you took out your calculator, you did 1 divided by 0.5, you would get that the average speed for this walker is 2 meters per second. How did I get 2 meters per second? Well, it's a distance over a time, so it'd be meters per second, right? Because I'm given meters and I'm given seconds. Okay, let's look at the next one here. What is the difference between velocity and speed? That is a great question, right? So in class, we learned about vector and scalar quantities. So we have velocity and we have speed. So we said that velocity was a vector quantity. So just like our Despicable Me character, right? Vectors have both magnitude and direction. Okay, and by magnitude, I just mean how fast or how slow. All right, and speed, all this depends on is magnitude, okay? So it does not depend upon direction, so we know that it is a scalar quantity. Okay? Awesome. Let's keep going. So calculate the distance you will travel if you maintain an average speed of 10 meters per second for 40 seconds. Like, again, this is a physics problem, so we write down what we are given. We are given a velocity that I did not write down correctly. We are given a speed of 10 meters per second. And what was our time? Our time was 40 seconds, and we are asked to calculate the distance. So D is equal to question mark. So you can look at your equation sheet and figure this out. I do not have an equation sheet handy to me now, so I am going to go ahead and rearrange this equation, our little velocity equation, in order to solve for the distance. So we can say that D is equal to ST. So in order to do this, we just plug in our information, and D would be equal to 400 meters. Right, because our seconds cancel here and we are just left with meters, which is great because that is what we wanted. All right, let's move on to the next one. Calculate the time it takes for a dog to travel 1,000 meters at an average speed of 1.5 meters per second. So I'm given a speed and I am given a distance. And I am asked to solve for time. Right, so calculate the time. I'm given a distance, I'm given some speed here. So in order to do that, I'm going to go ahead and rewrite my equation, solve it out. So time is equal to distance over speed. All right, so t is equal to 1,000 meters divided by 1.5 meters per second. And I'm going to be left with seconds here. So I go ahead and grab my calculator and I do this out and I get a very scary number, 666.67 seconds. All right, let's go on to the next one. Calculate the acceleration of a car in meters per second squared that go from rest to 100 meters in 10 seconds. So let's start by drawing a little car here. So my car is going to travel for 10 seconds until it reaches 100 meters per second, and we are asked to solve for the acceleration. Right, calculate the acceleration. So we know that it goes from rest. So rest indicates to us that our initial velocity is 0 meters per second. All right, so let's write down what we have. So we have an initial velocity of 0 meters per second, a final velocity of 100 meters per second, and a time of 10 seconds. All right, so now we actually write down our equation for acceleration, which is the change in velocity all over time, or VF minus VI all over time. So 100 meters per second minus 0 meters per second, all divided by 10 seconds, and we get an acceleration of 10 meters per second squared. So a person is standing on the edge of a cliff throwing a ball into the air. The person throws the ball into the air with a velocity of 20 meters per second. What time will the ball reach its peak height? So we are a person standing on the edge of a cliff for some reason, and we are throwing a ball into the air. And we know that this ball is going to travel up, reach a peak height, and then start to travel back down. Okay, so we are asked to solve for the time it would take for the object to reach its peak height right here. All right, so we start with a velocity. We are given a velocity here of 20 meters per second. So the person throws the ball into the air with a velocity of 20 meters per second. So the person is taking that ball and throwing it into the air. All right, so this would be our initial velocity. The ball was starting with 20 meters per second of velocity. Okay, and now it's super important to note what happens at the peak height of this ball. Well, the acceleration stays the same throughout the entire motion. So let's just draw on that acceleration, always acting down on that ball there. And our acceleration is the acceleration due to gravity, which is g. Okay, so g is constantly working down on that ball. So what happens at that peak height? Well, g stays the same, but our final velocity, or the velocity at that peak height, is actually 0 meters per second. And if it wasn't 0 meters per second, right, that ball would just keep going up into space. It'd be really easy to get into space. But because gravity is constantly pushing down on that ball, causing it to slow down, come to a stop, and then start to pick up speed downward, we know that at that peak position, the final velocity of that ball is going to be 0 meters per second. So we are asked to solve for the time, and our acceleration due to gravity is negative 10 meters per second squared. All right, so let's solve out the time and plug in our information here. So be 0 minus 20 meters per second all over negative 10 meters per second squared. So we get a time of 2 seconds. All right, I know this video was super quick and kind of rushed, but if you have any questions, please let me know. See you all soon.